Hello, welcome to Chapter 5, Probability. One easy example where probability is in real life is with lottery tickets. This guy thinks it's pretty smart to buy a lottery ticket, but is it really that smart? A recent Lotto Max draw for $70 million is when you go buy a $5 ticket. Your odds of winning, if you bought one ticket, you had a 1 in 33,294,800. So 1 in 33,294,800. Chance of winning that $70 million if you bought it. Now, what does that really mean, the odds of winning that? So that would be similar to, if there's a map of our wonderful country, if you took and wrote on a piece of paper the first name of every single person who lived in Canada, if you wrote their first name on a piece of paper, and then put all of those pieces of paper into a hat, and then your goal was to draw your best friend's name out of the hat with all those names in it. The likelihood of that happening is almost identical to the likelihood of buying one lottery ticket and winning that Lotto Max $70 million prize. So it kind of shows what your odds are, or the possibility that you're going to actually win the lottery. Okay, so not really super good. Okay, I mean, you could just sit back and be like, well, at least I have a friend. I mean, for some of us, maybe you don't have that. So you could just be like, yeah, I have a friend. So that'd be kind of exciting. Okay, so anyways, playing the lottery. Yep. Smart. Anyways, some other real life examples. Okay, weather forecast. The probability. What's the probability that will snow today? Or here we have either weather people say 30% chance of rain today. Okay, the opposite side of that is 70% chance that it won't rain today. Okay, gambling. So anything, we already talked about lottery, but going to Las Vegas or to a casino and thinking you're going to win big. Okay, and these are real life examples of playing the probability, the odds of winning and getting the outcome that you want. Okay, so those are some things that we're going to talk about in this chapter. So here are the outcomes we're going to cover. And at the end, we want you to be able to do this. I will express probabilities as ratios, fractions, and percents. We're going to talk about that one today. I will explain, provide, and understand the sample space for a probability experiment involving two independent events. Okay, we'll get to that beginning of the next week. We will conduct probability experiments to compare theoretical and experimental probability. Okay, so there's two types of probability that we are going to worry about. Okay, so a quick review of terms. I think I can write on this. Okay, a quick review of terms. So fractions, we all know, if we go back to this one, the first one here. Okay. I will express probabilities as fractions, ratios, and percents. So fractions, for example, 3/4 is a fraction, 0/4. Okay, we take that and we have a ratio. And the way that ratio looks is basically, one way to look at it is you take the fraction and you lay it on its side. So the numerator is the first, and then the denominator is second. Okay, so you're comparing two things there when you're looking at a ratio. Okay, so this is a 3/4, same as when you would say that for a fraction, 3/4. Okay, we have 3/4 things. So as a percent, 3/4 as a percent is going to be 75%. Now, again, for a review, if you don't remember how I got this into this, I went 3 divided by 4 and then multiplied that by 100. So 3 divided by 4 gives you 0.75. Then you multiply that by 100 and that gives you 75. And then you add the percent sign. Okay, percent again meaning out of 100. Okay, so if you're going to go backwards, if you have the percent and you want to turn the percent, so if we're going back the other way, oh, it's on the little eraser. We're going back the other way. Okay, and you're at 75%. Okay, so we went back to a fraction here. We dropped the percentage sign and we put it over 100. Okay, remember percent sign means out of 100. So we have 75 out of 100. Okay, and now once I'm here, I would then reduce. So in this one, reducing is easy, but you're going to divide this by 25. Okay, you're using the greatest common factor. And you're going to divide those. See, I paused there. I had to remember, make sure I said the wrong thing. Not the lowest common multiple, but the greatest common factor. Okay, so you reduce that. So you got to remember, be able to do those. Okay, most of these are going to be fairly easy numbers to work with, as you'll see from the example. So there's a quick review of the terms: fractions, ratios, and percents. Okay, fractions and percents. Hey, we're missing a colon on this one. Fractions and percents, we've worked out those this year lots. Ratios are grade 5, grade 6. We have talked about those. Okay, new terms to know. So if we had our notebooks, if we were in class right now, hi, no one's here, then we would write these things down. So an outcome, we're talking about probability. The outcome is one possible result of a probability experiment. So the outcome is what happens or occurs. So for example, if I take this die right here and I roll it, it landed on a 6. Okay, the outcome is what the number or what side this lands on. Okay, on a 2 that time. So the outcome is 2. Okay, so buying a lottery ticket, how many possible outcomes are there for that? There's 2. You can either win or you can not win. Okay, we could get into all these different things, like you could win a free play, or you could win $1,000, you could win one of the $1 million, or you could win the whole thing. Okay, but the outcome is any of those possibilities that happen after you buy the ticket. What can occur? Okay, a favorable outcome. Favorable, that sounds good. Okay, so that's the successful result. So what you want to happen, okay, is a favorable result. So if I take this die and if I'm playing a game, I'm playing aggravation, favorite game of my kids, okay, if I need a 2, okay, the favorable outcome is rolling the 2. I roll it. Hey, look, I actually did roll a 2. There you go. A 2, okay, so I got the favorable outcome. So that's what I wanted to happen. Okay, successful result in a probability experiment. Flipping a coin, heads or tails, and you want to get tails, you flip it, and you get tails. Okay, there's one possible favorable outcome. That's your favorable outcome. Okay, so probability. So you'll notice there is the capital P in brackets. We'll get to that in a second here. So the capital P is important. So that's the likelihood or the chance that an event will occur. So what's the probability of rolling a 6 when I roll this die 1 time? Okay, so the probability. Okay, that we can express as a fraction, a ratio, and a percent. Ratio. Okay, so you'll notice it's already written there, sort of like a little formula. Okay, it looks very similar to a equation, but also on the right there, sort of looks like a fraction, you'll notice. Okay, so probability. So you see the line here in the brackets. Here, on that line, is what you're going to write the favorable outcome, or what you want to happen. So I'm going to use an example with the die. If I need it to be, oh, this is a trick die. Didn't even notice that. Not very smart. Okay. There's 3 6s and 3 2s. Wow, good job. We'll get a different one. Okay, this one's a normal die. Okay, so if I need a 2, so the outcome I want here is a 2. Okay, so on the top, when we're listing our probability, total favorable or desired outcomes, how many times is 2 occur on a die, a regular normal die? It occurs 1 time. So on the top, I would put a 1. How many total possible outcomes are there when I roll this die? Well, this is a regular 6-sided die, so there are 6 possible outcomes. Okay, so the probability of getting a 2 is 1 out of 6. So I roll once, I have a 1 out of 6 chance of rolling a 2. And you probably won't believe it, but I just rolled a 2. And I rolled a 5. Okay, so you have a 1 out of 6 chance. So then if you're writing this, so you wouldn't have all those words there, you would put P. If you also want to put a 2 equals 1 out of 6. Okay, that's how you're going to write out the probability of getting a 2 on a single roll for a die, 1 out of 2. Okay, now we're going to use this information here going forward. Now again, said in the outcomes there, we're going to talk about the two types of probabilities, theoretical and experimental. Okay, we're starting with theoretical, meaning in theory this will happen. Now some of you would have experienced in a game when you're playing with a die. For example, we played aggravation yesterday with my kids, and Oscar, in aggravation you roll a 1 or a 6, you get to come out, you roll a 6, you get to roll again. He rolled 4 6s in a row. Okay, the chance of that happening, again, we're going to get into that. We'll get into that later, but okay, 1 in 6 chance of rolling a 6, boom, rolls a 6. 1 in 6 chance, boom, rolls a 6. Again. Okay, now, just to throw this in there, remember there's a wide range of probabilities. So down on the left here, we have the impossible, so 0 chance. Okay, something like, think of something right now that is impossible of happening. In the next 4 seconds, me growing a full head of hair. 1, 2, 3, 4. Yep, didn't happen. It's impossible. Okay, something certain. Me having no hair in the next 4 seconds. 1, 2, 3, 4. Yep, certain 100% chance. Okay, so another example, if you were using a die, the possibility on a normal die to get a 0. Okay, that's impossible. There is no 0 on the die. Okay, a certain possibility to roll this die and have it land on a number 1 through 6. That would be 100% probability, sorry. So probability of getting a 0 with your die would be 0 out of 6. Okay, probability of getting 1, 2, 3, 4, 5, 6. Yes, you can put all that in there. Would be, there's 6 out of 6. And you can't even see that because my mug is right in the way. Okay? Got it. No one cares. Hide my face. Perfect. Okay, so then you see things unlikely, something's unlikely, like you winning. There is a possibility of you winning the lottery when you buy a ticket, but it's down here on the unlikely area. Okay, very down in here. Okay, likely. It's cloudy outside. Look at what are the chances it's going to rain. Dark clouds outside. Okay, it doesn't mean it's going to rain for sure, but it's very likely that it will rain. All right, now, that is what probability is. And so now we're going to do some examples. And so for today, we're just going to practice using this scenario here, or writing probabilities out this way, okay, in a little formula or in a little equation. So here's the first one. Okay, again, it's kind of hard. You can see my face. Get out of the way, Mr. Davis. Okay. Okay, so we see some airplanes there. There's a red one, a blue one, a black or gray one, whatever you want, or I guess it's silver in the question, yellow, purple, and orange. 6 airplanes waiting to land at an air show. Show the following probabilities as a fraction. Okay, and just for this question, just to show you doing the ratio, we're going to do all of them. Okay, the first plane to land will be blue or purple. Okay, so for A, let's put it on a pencil here. A, so the capital P, and then in the brackets, what do I want to occur? I want it to be a blue or a purple. So in there I would put blue or purple. Okay, now on the bottom again, just so you remember, look on the bottom again, total possible outcomes. How many possible outcomes are there in this one of being the first plane to land? There are 6 airplanes, so there's 6 possible outcomes. The top one is the total number of favorable outcomes. So favorable for this, if you look back over here, this is going to match what we have here. How many blue or purple ones are there? There's a blue one and there's a purple one. So there are 2. So this would be 2. Okay? So show the probability. It would be a 2 over 6. So a 2 out of 6 chance that the blue or purple would land first. Okay, now in this, of course, we can reduce this. We're going to divide by 2, divide by 2. That'll be 1 over 3. Okay, so you would write 1 over 3. Then as a ratio, again, I would turn that the numerators first. And there it is as a ratio. And then as a percent, I would take 1 divided by 3 times 100. And that would give me 33.3% chance. Okay, B, probability. The first plane to land will be silver. So then capital P, silver. Good job. So the bottom one, total possible outcomes. Again, there are still 6 airplanes. And I want silver. How many silver are there? There's 1. Okay, so we'd have 1 silver airplane. Can I reduce that? I cannot. 1 over 6. To make it a ratio, I would turn it on its side. 1 to 6, and as a percent, it would be 16.7%. Spinner is spinning a spinner, so this has like a little arrow on it, right? And you flick that with your finger. Okay, so on this one, the question is, what's probability of landing on an F? So again, probability, what do we want to happen? F, okay? And then, again, same thing. Bottom, or the denominator there, is the total possible outcome. So on this one, there are 4 possible outcomes. We have F, G, H, I. Okay, so there's 4. How many out of those 4, how many match my desired outcome, or the F? And on this one, there's 1. So you have a 1 in 4 chance every time I spin this spinner of it landing on the F. 1 in 4 chance. Okay, now the important thing is, you'll notice the space, okay, for each of these is exactly the same, okay? So there's no little trickery here where the F is a little bit smaller and the G is bigger. Okay, we're not going to get into stuff like that. They're always going to be evenly spaced things. Now you might have some where maybe there's 2 F's on here, okay, something like that. Okay, but for this one, here we go. So 1 out of 4. Now let's say I want to put that into a ratio. Okay, so again, numerator first, and then as percent. 1 out of 4, as you know, 1 divided by 4 is 0.25 times 100 gives me 25%. So I have a 25% chance every time I spin this spinner of it landing on the F. Okay? Next one. What is the probability of landing on an F or a G? Okay, so again, P. Think about for a sec, what are you going to put inside our brackets here? What do we want to happen? That's where we look up here. We want F or G. What goes on the bottom again? Total possible outcomes on this one. There are 4 spots, 4. And then what is the probability of getting this, or how many out of those 4 spots, okay, are an F or a G? Looks to me like all of them. So there's 4. So this one is one example of 100% probability. I spin this spinner, it's going to land on F or G no matter what. Okay, or a 100% chance of it occurring. Probability of landing on blue. Probability, blue, is how many total possible outcomes when I spin it. There are 5 possible places for it to stop. Top one is how many spaces out of those 5 give me what I want, or my favorable outcome. There's only 1 that's blue, so it'd be 1. 1 in 5. So then you, as a ratio, 1 to 5, or as a percent, 1 divided by 5 times 100 is 20%. This is brought to you by Notability, I guess. Wonderful sponsor for our class. Okay, have a great day.